Today we're talking about Chapter 6 or Chapter 1, Section 6, other types of equations. All right, so what does it mean by other types of equations? Well, so far we've talked about linear equations. Linear equations are equations that have a variable that are raised to the first power, like 3x plus 4, or just simply 4x, right? Uh, we've talked about second order equations. Those are your equations raised to the second power, right? X squared and then plus, like 3x, something like that. We call those quadratic. All right, well, now we're going to talk about other equations. So basically, equations that are higher degree than 2. And of course, that's what this says. But probably, I'm just gonna guess, probably a lot more eloquent than I put it. But I don't know, we'll see. I'll let you guys be the judge. Alrighty, so how do we tackle this? So this is a third degree polynomial. Okay, I say third degree because you can tell that the leading term, the highest coefficient, the highest degree of exponent I have there is 3. Okay, so it's a third degree polynomial. So what we're going to do in order to solve this is kind of start the exact same way we always do. Okay, so what we're going to do is put everything on one side, and then we're going to factor. All right, so let's do that. So let's go ahead and rewrite this and put everything on one side. So we're going to have 3x cubed, and then we're going to put this in descending order. So descending order, that would be a plus 5x squared plus 2x. I'm sorry, minus 2x. Which, by the way, is well, no, never mind. Okay, so minus 2x. That's going to be equal to 0. All right. Actually, that does kind of bring me to that. So last lecture, if you recall, kind of struggled there on the last part. That's because when I moved it from the right to the left, I didn't change the sign. So if you recall the last example on Monday, I was like, well, this isn't right. That was the issue. So hopefully you figured it out before I did. But anyways, or at least figured it out, maybe not before I did. But anyways, once put everything on one side, now the first thing I have to do is factor. Okay. That is the first step in pretty much every single math problem. Start with factoring, okay? Factor starts with F. You don't want to get an F, so get the F out of the way and factor. I don't know. Ooh, I didn't mean to say get the F out of the way like that, but you know what I mean. Hopefully, I've actually never went that route, so that's never happened to me. My bad. But anyways, so as we move on, we're going to factor out an x, okay? So pulling an x out, so it looks like, again, in all these terms, well, I guess I'll have to underline everything. Looks like I have an x here, and x here, okay? I can factor an x out, but I can't factor a number out because 3, 5, and 2, they have no common terms, or they don't have any factors in common, okay? So I'm going to pull an x out, and then that leaves 3x squared plus 5x minus 2. That's going to be equal to 0. Okay. And then now we got the 3x squared plus 5x minus 2. All right, so now we went from a third degree polynomial to a second degree polynomial. And we have the tools to solve a second degree polynomial. Those tools being either factoring or there is a second one, the square root method, but I told you guys don't mess with that yet until we get to circles. But we had the factoring or the quadratic formula. Okay. Well, this could be done with both, but we want to solve this and we want to have kind of like x is equal to, and we can do that with the quadratic formula. Okay, but I'm going to go about it with factoring because I feel like the factoring part is what trips a lot of people up. The quadratic formula, it's plug and chug, right? Factoring, not so much. So let's do a factoring one. Okay, so recall that this is the AC method. I look at A, I look at C. So again, A times C, this is the AC method. A is 3 times C, and I'm just going to use the positive component of it, right? 2, it's going to be 6. What are my factors of 6? Well, 1 times 6, 2 times 3, and then we go to 3 times 2, and we just kind of repeat. Okay, and so those are my factors. And this is interesting. Okay, so because in the past I said, okay, so looking at these factors over here, which one of them, when you add or subtract them together, will give you a positive 5? Well, actually, both of them will, won't they? Okay, so that's interesting. They'll both give you a positive 5. All right. In the other examples, you basically only have one that'll give you the solution, but this time we have two. Okay, because again, a positive 6 and a negative 1 will give me a positive 5, and a positive 3 and a positive 2 will give me a positive 5. Okay, so this is where we have to think about the negative sign, the negative 6. Okay, so if you recall, I did say at the beginning, I did 3 times 2, and I said we're going to take the positive component because if we took the negative of it, again, a negative 6 can be achieved by saying 1 times negative 6 or negative 1 times 6. So I just leave the negative out. But now we're going to have to come back and think about it. Okay. So now what we're going to have to do is we're going to say, okay, so which one of these, when you add or subtract them together, will give you a positive 5, and the answer is both of them, but will also give you a negative 6. Okay, so it is kind of confusing. There's an extra step involved here, but it's not too much harder. Okay, so getting a positive 5, we would need a positive 6 and a negative 1. Getting a positive 5 from the 2 and 3, we need a positive 2 and a positive 3. Okay, so that makes sense. All right, well, which one of those, when you multiply them together, will give you a negative 6? Okay, and the only one that'll give you the negative 6 is the 6 and negative 1. So that's the one we're going to use. Okay. Alright, so let's rewrite this now. We have an x, and then we're going to rewrite this as 3x squared. We're going to keep that there. And then we said we're going to rewrite that plus 5 as, we're going to rewrite it as a, let's put it in yellow, we're going to put it as a plus 6x, and then a minus x, and then minus 2. Okay, and then if we do that right, all we have to do now is factor by grouping. Okay, and so, and again, notice how I'm bringing this x down every time. Okay, so people forget this x quite often, but remember that it goes along with it. All right, so what can I factor out of the left side here? Well, looks like I can factor the left side of the dotted blue line here. It looks like I can factor a 3x out, so 3x, and what remains would be an x, looks like plus 2. Right, and then over here, I'm going to factor out a negative 1, and what remains would be an x plus 2. Okay, and then put another parentheses here because it closes off this parentheses, right? The one next to the starting x. Right, and then we can finish this up. We say x, and then looks like we can factor the x plus 2 out, and what remains would be 3x minus 1. It's equal to 0. And so this tells me that my x values, okay, again, if I set all these equal to 0, if I set that equal to 0, I would have x is equal to 0. If I set this equal to 0, I would have x is equal to negative 2. And if I set this equal to 0, I would have x is equal to a positive 1/3. All right. One moment. All right, sorry. I'm still feeling a little under the weather, so still have a little fits there every now and then. Alrighty, so factor by grouping again. Oh no, it's not necessarily again. Okay, so I said again because we did example 1 by factor by grouping. I guess maybe they would have just wanted it not done that way, but trust me, do it that way. It's a lot easier. Okay, so now we can do factor by grouping again. All right, so here's the rule of thumb. This is what you need to write down. Okay, and I'll pause a second and let you write it down. if you see four terms, okay, actually let's do this. One term, two terms, three terms, four terms. If you see four terms in an algebra problem, the very first thing you need to think is factor by grouping. Okay, I'll give you a few seconds to write that down. If you see four terms, you need to think factor by grouping. Okay, so let's rewrite this. So we're going to say 2x cubed. And I don't know if this is going to be nice and pretty. And it looks like it is. So I'm going to rearrange it a tad, okay? Because I'm pretty sure you might have a problem like this. We'll do plus 8x minus x squared minus 4. Okay, so I rearranged it because you might have a problem like this. The first thing you think is factor by grouping, okay? So we're gonna do, and is that still gonna work? All right, we're just gonna do it anyways. Okay, so what you're gonna do is you're gonna split it down the middle. Okay, so split it down the middle, and so what can we factor out of the left side? Well, it looks like we can pull a 2x out over here. What remains looks like an x squared plus 4. Okay, so that didn't work like I thought it would. Okay, so heck, I don't know. I'm trying to think of a way I can make this be an example of a harder problem. Maybe this would be it. Actually, I don't even know if you guys will go over that in this course. I might be thinking pre-cal algebra. So let's just proceed like this. Okay. Don't want to fill your head with too much stuff. But anyways, first thing we're going to do, again, I see four terms, so I'm going to try to factor by grouping first. Okay, so the left side there, it looks like I can factor an x squared out. So I factor an x squared out, and what remains looks like a 2 minus, 2x minus 1. Right, and then what can I factor out of the right side there? It looks like I can factor a 2 out. Okay, so I must make it a positive. I can factor a positive 2 out, and what remains would be a 2x minus 1 again. Okay, and then similar to the last problem, again, what can I factor out of here? And I don't know if I went over this before, so I'm going to be a lot clearer now. If it isn't apparent to you, and let's make it apparent. Actually, I do remember saying something like this in the first lecture. Shouldn't that 2 be a 4? Yeah, it should be a 4. Yeah, thank you. I'm factoring a 4 out, not a 2. Sorry about that. All right, so do that, and then plus 4, 2x minus 1. Alrighty, so I guess do I have to check it? Okay, so if this doesn't make it apparent, I'll try a different way. But if you look at this problem, you notice how this is the first term. Okay, again, these terms are separated by an addition or subtraction sign. This is the second term. Okay, notice how in both terms they both have a 2x minus 1. Okay, so imagine if this were, I think I did because I did alpha. So imagine if this was x squared, and let's just make it a y, and then plus 4, and then a y. Okay, if you had this particular problem, it's very easy to see that you would indeed factor a y out. Okay, so that's essentially what we're doing with the problem here. Okay, there is a 2x minus 1 in both terms, so we're going to factor that 2x minus 1 out of both those terms. Okay, similar to how we would factor the y out of this term, this bottom problem down here, x squared plus 4, and we'd be done. Okay, so that's the same kind of thought process. Actually, I guess I can erase everything. So by factoring that 2x minus 1 out, we'll have 2x minus 1 that gets factored out. And what remains will be the x squared plus 4. So that would just be by itself x squared plus 4 is equal to 0. And then my values of x, well, it looks like we're going to have an imaginary number here, right? So the first x, this one, is going to be x is equal to a positive 1/2. And then this one is going to be x is equal to a plus or minus 2i. Okay, and if you forget, let's go over here and look. You would say x squared plus 4 is equal to 0. X squared is equal to negative 4. X is equal to plus or minus the square root of negative 4. You pull the I out, and the square root of 4 is 2. So that's how we get 2i. Plus or minus 2i. Okay. Okay, so here's some more problems, and they do get a little tricky, and you're gonna think, oh, this is dumb. I'm very, very not in the mood to do, fractional exponents, right? Or whatever this mess is. But they're not that difficult once you know how to mess with them, okay? And the thing is, now here's how thought process works. When you problem solve anything in life, right? It's not just math, but anything in life. What you do is you try to relate your current problem, or your brain does. Your brain relates your current problem with the problem that you've had earlier, right? And how you solved the problem earlier is how you're going to solve the problem now. One moment again. Okay, so however you solved a problem before is how your brain, or is what your brain uses to solve the next problem. So what we're going to do here is kind of use is that same process, as your brain has not seen this before, or any of them, right? But it has seen something like it, all right? And here's what it has seen like it. Okay, so what we're going to do, we're just going to look strictly at A for right now. Okay, and what we're going to do is we're going to say we're going to let x squared be equal to we'll say u. Okay. All right. So here's the thing. Before I do proceed, let's look at this. Okay. So this is the quadratic equation. Quadratic equation just being ax squared plus bx plus c is equal to 0. All right. So what we're going to look at here is we're just going to look at the variable. Okay. Notice how the first variable is exactly the square of the second variable. Right? Likewise, the second variable is the square root of the first variable, right? Ax squared plus bx. The first variable is the square of it. Okay. So notice how in this particular problem in A, x to the fourth is exactly the square of x squared. Okay, and we're going to actually see that in all of these. Okay, there is the first variable is exactly the square of the second variable. So if you took the second variable and you squared it, you will get the first variable. If we took x and squared it, we get x squared. If we took x squared and squared it, we'd get x to the fourth. This one's a little hard to see, so we'll get to that in a moment. But if you took x to the 1/3 and squared it, you get x to the 2/3. If you got x up here, let's see, right here now. If we took x to the -1 power and squared it, well, it wouldn't actually be the 5, sorry, just be the x. If we squared that, then we get x to the -2. Okay, so notice how in every one of those cases, and again, B is a little differently looking, but I'll touch on it in a moment. But all the ones that are apparent, that yes, indeed, the first variable is indeed the square of the second variable. So what we're going to do is we're going to concentrate on that second variable. Okay, so the second variable here is an x squared. So we're going to talk about that x squared, and what we're going to do is we're going to change it into a u. Okay, so why do we pick u? I don't know, it's used a lot. They actually called u sub. We use it a lot in calculus, and I guess it just kind of trickles down to this course as well. Or is it the other way? I don't know. But anyways, so we're going to let x squared equal u. So now I'm going to rewrite this problem. Okay, so this problem now becomes 2u squared minus 11u plus 12 is equal to 0. Okay, because I let u equal to x squared. And by letting that happen, I can now rewrite the problem as 2u squared minus 11u plus 12. Okay, now it is the exact same problem, the exact same. Okay, if I make sure that I have the let x squared equal u be a part of it. Right? Now, of course, it has to be part of it for us to do it this way. All right, well, 2u squared minus 11u plus 12, well, that is now easily factorable. Okay, so we can factor that into, 2u minus 3 and into u minus 4, okay, is equal to 0. Okay, and again, AC method, but usually with a 2 in front, they're pretty easy to factor in your head. But anyway, so we have 2u minus 3 and u minus 4, so I end up with u is equal to, looks like a 3/2, and u is equal to a positive 4. Okay, but that's not the end of the story, because this problem did not start out with u's, did it? Okay, if you were given this problem and you finished here, you would be incorrect. Okay, because the original problem had x's. So what we're going to have to do now is we're going to have to do the exact same substitution again. Okay, so you're basically just substituting back, but I'm going to write it anyway. So now we're going to say let u equal to x squared. Okay, so now what happens is now this becomes x squared is equal to 3/2, and x squared is equal to 4. Okay, all I did was change this 3/2, u equals 3/2 into x squared equals 3/2, and this u equals 4 into x squared equals 4. Okay, because earlier I said let x squared equal u, now I'm going to let u equal x squared. Okay, so now we're in business. So now we can proceed, and so this problem now becomes, all right, so if we solve for x, we take square root of both sides, we have x is equal to plus or minus the square root of 3/2, and x is equal to plus or minus 2. Okay, and that's that. And of course we could rationalize the denominator on this particular problem. And let's actually go ahead and rationalize it, because I'm pretty sure the homework will want you to rationalize it. So let's go ahead and rationalize this. All right. So the square root of 3/2 is the square root of 3 over the square root of 2. And so we want to get rid of that square root of 2 on the denominator, so we multiply it by the square root of 2. If we do it to the denominator, if we do it to the numerator. So we have the square root of 6 over 2. Okay. So this actually now becomes the square root of 6 over 2 as a solution. All right, so that was A. Okay, now again, once you see it and you work through a couple of them, I feel like it'd be a lot faster for you. B is a little trickier, so we'll touch that here in a moment. Well, as of right now, so let me go ahead and snip example 3 again. And we'll do B. Okay, so we have B. Alrighty, so I said it's a little different, and here's why. We have it's not maybe it's not readily apparent what my variable is, right? So if I've got a 1 over x minus 2 quantity squared, and I've got a plus 2 over x minus 2, right? So let's move this down. We got fractions. So what I'm going to do is I'm going to rewrite this now as the first one is going to stay the same. The second one, okay, I need my middle term to look like this, right? So in order for that to happen, I'm going to put the 2 out front, and now I have it look like the first term. Okay, I can't put a flag on that one for some reason. Okay, so what this becomes, see, let's see, if I were to take this and multiply this 2 by 1 over x minus 2, I would indeed get 2 over x minus 2. Okay, so it is the same thing. It's just now I make it look like the first term, and so now it makes it so apparent what my u substitution will be. Okay, so let's go ahead and make that u substitution. So we're going to say let u equal to, let's see, how did I do it last time? I put the x squared first. We're going to do that first again here. We're going to try to stay consistent. So we're going to say let 1 over x minus 2 equal to u. And by doing that, again, now I'm going to have u squared plus 2u minus 15 is equal to 0. Okay, and this factors pretty easily. We have it factor into 3 and a 5, so we've got u plus 5, looks like, yeah. And then u minus 3 is equal to 0. So same thing. I have u is equal to a negative 5, and u is equal to a positive 3. But again, we didn't start out with a u, so what we're going to do is we're going to make that substitution again. So now we're going to say let u equal to 1 over x minus 2. And I'm quickly running out of room here. So I've got 1 over x minus 2 is equal to negative 5. And 1 over x minus 2 is equal to 3. And then we proceed that way. Okay, I will stop there. Okay, these are not the correct solutions. It's just at this point in time, I feel like you can, if you're given this problem in an algebra course, you can solve it from here. Okay, so let's go to C. All right, so C, same thing. I'm just gonna go ahead and write the substitution here. Okay, so let's go ahead and just start with the substitution. So we're gonna say let. Looks like we're going to let x to the 1/3. That's not happening. Third. Right, again, small movements just aren't really liked here. So x to the 1/3, we're going to make that equal to u. So this becomes u squared minus 9u plus 8 is equal to 0. Same thing, one of my factors of 8 looks like it's going to be negative and negative, right? So we're going to say u minus 8 and u minus 1. That's going to be equal to 0. I've got u is equal to 8, u is equal to 1. Again, just do that substitution. Let u equal to x to the 1/3. So this becomes x to the 1/3 is equal to 8, and x to the 1/3 is equal to 1. All right. And how do I go about this? Well, how do I clear an x to the 1/3? Well, I need to, if it's a cube root, I have to cube it. Okay. So what I will do here is I will cube. Let's see. Just don't like how that little b3 looks. 3. 3, and then we're going to cube this other side. Okay, and so this means I've got x is equal to, and I actually don't know what 8 cubed is off the top of my head. 512. So we have x equal to 512, and x is equal to 1. Okay, and I finished that one and not the previous one because I didn't want to have to pull up another sheet. But again, sometimes I just have to reiterate things. I feel like you guys can do that one. And then lastly, D. D. So let's just go ahead and do the substitution. I mean, I can immediately tell again, in all of these, I can tell that, okay, so this term is exactly the square of that term, right? Same thing like I said before. So what we're going to do is we're going to let x to the negative 1 be equal to, did I say 1/3 on the previous page? Yeah. X to the negative 1 be equal to u. So now I can easily do this as 3u squared minus 5u minus 2 is equal to 0. All right, and then we can proceed from there. All right, so A, B, C, D, they're all the same, and then just make sure the tough part would be, I won't say a tough part, but the two main takeaways here, I guess B looks is better in my opinion, is do the first substitution, okay, but always do the second substitution. All right. So those are two main takeaways when we do solving by substitution. Okay. So in D, just same thing as all of them. Pretty sure. Okay, yeah. So next we have square roots. Okay, so I have mentioned and I have demonstrated so far that I don't really check my solutions. Okay. We have talked about extraneous solutions being solutions that you can do things right algebraically, but you are wrong. Okay. We've talked about extraneous solutions, but those are pretty easy to spot because at the beginning of solving those problems, what you're going to do is you're going to basically find yourself and tell yourself what the restricted value is. Okay. For this, I've got bad news. If you see a square root, you're in for trouble. That's all it's doing. The square roots are just trouble, right? And the reason why is because A, it just sucks solving them. B, you actually have to plug them back in every single time. Okay, so you must plug your solution back into the square root every single time. I'm sorry, that's just the way it is. There's no easy way around it. I hate it just as much as you do. Okay, so here's what we're going to do. In order to solve these radical equations, all right, the ones involving square roots, we have to isolate the square root. Okay, so let's go ahead and start this problem off by isolating the square root. All right, so we have that. We're going to go ahead and add 2 to both sides. So we're going to have x, looks like minus 7. Okay. All right, so we went ahead and isolated the square root. So next thing we have to do is we have to square both sides. Okay, because it's a square root, and in order to get rid of the square root, we must square it. Well, if we square a square root, just the radicand is left. And then we square the right side. Now would probably be a decent time. Let's do this. Previous add page. Okay, so these are definitely going to have to be memorized and written down. I won't say definitely, but it helps. Okay. So if we have, I never knew you left. So if we have a plus b quantity squared, that's equal to a squared plus 2ab plus b squared. And if we have an a minus b quantity squared, we have a squared minus 2ab plus b squared. Okay, so these two formulas need to be memorized. You've seen them before. They are perfect squares, and this is what happens when you expand them. Okay, now here's the thing. Many people think all you need to do here is say, oh, a squared plus b squared. Okay, that is not true. You don't just simply distribute the 2 to both of them. Okay, that's not how exponents work. You know how exponents work. It's just you kind of go on autopilot and you think you can just distribute the 2. That's not how it works. Whenever you have that number up here, it tells you how many times you're multiplying it by. If this were 99, you would write a plus b 99 times and solve. Okay, so we notice I can't write fast on this tablet. But anyways, so you just write it out however many times it says. Okay, you do not distribute that 2. So with that said, let's move on now to this. I'm going to use the subtraction one, this one, for the x minus 7 quantity squared. Okay, so this becomes x squared minus, and it's 2 times a times b, so 2 times a, which is 1, so it's 2, 2x rather. And then b is a negative 7, so it's going to be minus a 14x, and then plus 49. Okay. And then we're going to put everything on one side, so we're going to say, we're just going to put everything to the right side. We're going to subtract x and add 1, so we're going to have x squared minus 15x, I'm sorry, minus 13x, and then plus 50. Okay. All right, so x squared minus 15x plus 50, well, that factors pretty easily into x, then minus 10. Yeah. 10x minus 5. Okay. And so this tells me my solutions are going to be, let's just put the solutions up here. They're going to be x is equal to a positive 10 and x is equal to a positive 5. Okay, we're not done though. Okay, again, every other time I stop right here. I'm like, all right, let's move on, right? Or I'll recap. But we're not done. We have got to plug these in. Again, there's just no way around it. We have to do it. Okay, so we're going to do some mental math here. Should the 13x be a 15x? Yeah, it should be. I thought I said 15. Yeah, I had to if I factor it that way. So the way we do this, we're just going to plug these values in to my original equation. Okay, we're going to do some mental math here. Okay, so we're going to use 10 first. So if we plug a 10 in for x into this radical, we end up with 10 minus 9, which is, I'm sorry, 10 minus 1, which is 9, square root of 9 is 3, so it's a 3 right here. Let's put a 3. Okay, we'll put a 3 here. 3 minus 2 is 1. Perfect. All right. And then we have, on the right side, 10 minus 9, well, that is also 1. So we have 3 minus 2 is 1, and 1 is equal to 1. So this tells me that, yes, indeed, x equals 10 is a solution. Okay. 1 second. All right, sorry. Where was I at? Okay, yeah, now we do the 5. 1 second. Sorry. All right. Now we do the 5. So we're going to put the 5 in over here. Okay. So 5 minus 1 is 4. Square root of 4 is 2. So that's a 2. 2 minus 2 is 0. 0 is on the left side. And if I put in a 5 for the right side here, 5 minus 4 is a negative, I'm sorry, 5 minus 9 is a negative 4. And so 0 does not equal to -4, so therefore 5 is not a solution. So my only solution to this problem is x is equal to 10. Okay, again, there's no easy way around it. That's just how it is. All right. I'm pretty sure the next problem is even worse. The next problem is a nightmare. Hope y'all are ready. Yep, there it is. All right, so again, there's no easy way around this. We just have to get rid of each radical one at a time. Doesn't matter which one you get rid of first because you're going to have to get rid of them both. Okay. So what I'm going to do is I'm going to go ahead and rewrite this. I'm going to isolate just basically the first radical first. So 2x plus 3. It's going to be equal to, we're going to go ahead and subtract the square root of x minus 2 from both sides. So we're going to say, there we go, minus the square root of x minus 2. Okay. All right. Here we go. I'm going to square both sides. Luckily, the left side's pretty easy. Again, I just have to rewrite it, right? So 2x plus 3. 2x plus 3 is equal to. All right, so this is in the form of a minus b quantity squared. Okay, so we're still going to proceed that way. Okay, so a squared, so 4 squared is 16. Okay, it's going to be minus 2 times a times b, so minus 2 times 4, which is 8, times b, which is square root of x minus 2, so it's going to be 8 on the square root of x minus 2. And then it's going to be plus, and luckily, this just turns into x plus x minus 2. Okay, now, if you need to, all right, and I'm okay if you do this, but if you are a normal human, you like to get done with things quickly and efficiently. Okay, if you're not a normal human, I'm sorry, I didn't mean to offend you. But if you want to, starting out, okay, especially on something like this problem, if you want to go ahead and do 4 minus the square root of x minus 2, and then 4 minus the square root of x minus 2, if you want to do this in FOIL, all right, that's fine, okay? But I do want you to eventually work your way up to the point, especially if you're going into a STEM field, of being able to just basically look and expand the problem like I just did, okay? Using the formulas here, okay? They're not difficult formulas. Matter of fact, they're the exact same. The only difference is one's plus, one's minus, but they do correspond with their sign there. Okay, so they're the exact same except for that. So if you just can memorize one, you basically have the other. Okay. But anyways, that's that. Okay, so we need to isolate the radical term again. So what we're going to do is we're going to move 16 over here, x over here, and 2 over there. Okay. So this turns into, so if I subtract x from both sides, I'll have an x over here. The 16 and the negative 2, well, that turns into a 14, so I'm going to subtract 14 from both sides. So it's going to end up being a negative 11, x minus 11. And that's going to be equal to a negative 8 on the square root of x minus 2. Okay. All right, so before I proceed, let me make sure I did that mental math correct. Right, everything looks good. 16, 14, minus 14. Okay, everything's good. All right. So again, we now that we've isolated that radical, the radical term, okay, we're going to square it as well. So we just have to do a bunch of squaring here. So square the left side, square the right side. So now we've got, on the left side we have x squared minus 2 times a times b, so it's going to be minus 22. X and then plus 121. And on the right side, all right, so let's focus on this real quick. Okay, because the thing you want to do all the time, you're allowed to do now. Okay, how earlier I told you that you can't just square the 4 and you can't just square that term. Okay, the reason why is because we have that symbol right here. Okay, a plus or a minus sign. In this particular case, it's a minus sign. All right. Now, if you don't have any sort of minus sign there, plus or minus sign rather, so you notice how we don't have anything there, we do indeed square those numbers. Okay, we can only do that when it's a multiplication, because this does still work by the rules of multiplication, right? And let me show you. So let's go over here. This would mean I would write that binomial twice. Okay, true. But this also means I'm writing it twice. Okay. Right. Well, if I dropped the parentheses here, okay, because it's just multiplication on top of multiplication, right? So if I just drop the parentheses there, it'd be -8, times the square root of x minus 2 times -8 times the square root of x minus 2. Okay, that works out because it's all multiplication, right? 3 times 4 times 5 is the same thing as 5 times 4 times 3. It all works out. So that's why what we can do, what you want to do all the time, and I say that, I mean, I don't know, you guys, maybe class of 2020 is a lot smarter than my previous cohorts. But I always have students always wanting to just simply square whenever we have the addition or subtraction sign there, and they just get it incorrect, right? So anyways, let's move on before I ramble too much. -8 squared is 64. Okay, and then if I square what is in the parentheses, that just becomes x minus 2. Right, and so this looks like it's going to be a nice problem. So let's go ahead and put this on another page. Okay, all right, so let's drop that parentheses on the right. So we have x squared minus 22x plus 121 is equal to 64x minus 128. All right, so now let's move everything to one side. So we're going to have x squared, and then be 86 minus 86x, and then we add that to 49 plus 249. That's ridiculous. All right, so if you can factor this in your head, good job. I cannot. I'm going to jump straight to the quadratic formula. So x squared minus 86. Okay. My solutions here using the quadratic formula would be x is equal to 3 and x is equal to 83. Okay, so let's go back and look at the original problem. All right, let's plug in a 3 into my original problem first. So if I plug in a 3, well, 2 times, again, I'm looking for the x. 2 times 3 is 6. 6 plus 3 is 9. The square root of 9 is 3, so we have 3 there. Plus, and then we've got 3 minus 2 is 1. The square root of 1 is 1. So 3 plus 1 is 4. That is indeed a true statement. So that tells me x minus 3, I'm sorry, x equal to 3 is a solution. So now let's do 83. Okay, so 2 times 83 is 166. 166 plus 3 is 169. The square root of 169 is 13. Plus 83 minus 2 is 81. Square root of 81 is 9. Okay, so we have 13 plus 9. 13 plus 9 does not equal to 4. So that means that 83 is not a solution. So my only solution here is x equal to 3. Okay. And lastly, a bit of good news. The thing I told you about, you always have to check your solutions with the square. That's true. You need to. Okay. But cubes, not so much. You ain't got to worry about the cubes, right? Because the reason why is because, well, for instance, if I squared a 2, I would get 4. If I squared a -2, I would also get 4. Okay. Well, cubes are different, okay, and we'll learn this later on, but the cube function is what is known as an odd function, okay, the way it's graphed. So negative 3 cubed is going to be negative 27, okay. There is no other way we can get to negative 27 by cubing it, okay. So that's the good news. You don't have to plug it back in. Okay, that's really it. I don't think there's much bad news here. So let's begin. First thing we're going to do is we're going to write my radical like this, and then I'm going to subtract 3 from both sides. All right, and then what I'm going to do is I'm going to, since it is a cube root, I'm going to cube both sides. Okay, so by cubing both sides, the left side now becomes an easy to manage 1 minus 4x. The right side becomes a negative 27. That actually worked out pretty nice, didn't it? All right, and then if I subtract 1 from both sides, I've got a negative 4x is equal to a negative 28. And then if I divide both sides by a negative 4, I've got x is equal to a positive 7. Okay. And then of course, I mean, you can, if you want to, check to see if that's true. But again, whenever we're dealing with cube roots, you don't have to. It's going to be true. Okay. We're going back to lazy math. All right. Anyways, that does conclude today's lecture.